Teacher knowledge and behavior is the component of the model that focuses on teachers' knowledge of students and content and on their expertise in classroom management and pedagogy. Teacher behavior is the element of teacher knowledge and behavior that encompasses classroom management and pedagogy. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 9th grade algebra class are learning about the factored form of quadratic equations. The teacher's management of a daily review session demonstrates content management, an element of classroom management. The discussion sets the stage for new learning.
The last couple of months we've been talking about different functions. We studied linear functions quite a bit. We looked at graphing linear functions, changing the slope, how that affects the graph. We looked at changing the y-intercepts and noticed what that could do to a graph. And then we started looking at data that was quadratic in nature. And we've been studying two different forms of quadratic equations. Who can raise their hand right now and tell me what the general form of a quadratic equation looks like? What's the general form look like? Come on, I think you know. Ashley?
Y equals ax squared minus bx plus cx. Sure. Yeah, no. Plus c.
Anybody want to change anything about that?
It's plus bx.
Plus bx? That's correct. Okay, that's the general form. Now, when I throw numbers in here for a, b, and c, it affects the graph. What important characteristics can you tell about the graph of a parabola when you change any one of those values? Or why would we study something in that form? Who can recall what the other form is called? You guys see here? Belinda, what's the other form?
Vertex form.
The vertex, good. And what's that form look like?
Y equals
How about I get you started? A?
a parentheses x times h parentheses squared plus k.
That's K. Okay, two forms. Why would you use the vertex form?
The teacher also demonstrates content management, part of classroom management, in her management of a preview session. She briefly outlines the lesson for the students.
Today we're going to learn another form, a third form. It's called the factored form. Okay, and I'm going to have you actually discover this form. What you guys are going to be doing is working in groups of 4. I think there'll be one group of 5. And what you will do is you will factor an equation that's in the general form. And you've done this. You did this last week. Some simple equations that you will be factoring. Then you'll take the graphing calculators and you'll type the equation into the calculator and you'll graph it. And then you'll look at the x-intercepts. And then, as you're doing this worksheet, you'll make some connections. You'll see some patterns, and you'll see easy, simple ways to factor equations using the x-intercepts.
Before the students break up into small groups, the teacher reviews the guidelines for cooperative group work. The teacher's management of the degree of accountability among the students demonstrates content management, part of classroom management. The teacher creates a sense of responsibility and belonging that facilitates effective group work.
Before we break off into groups, I need to review those two things over there on the wall. We have group guidelines. Whenever you're in your groups, remember to be courteous, contribute, be sure you're listening to one another. That's very important. I think most important is that last one that we've talked about before. You stay on the particular problem that you're on until everybody in your group understands what they're doing. Then you move on to the next one. Okay? And then the group roles that we have are listed over there also. Reader, you have to read through the problems, stay on the problem until everybody's finished with that one. Make sure everybody understands the directions. You can come and ask me for help if you don't understand the directions. The recorder, your job is to write down everything on paper. Remember that I will be assessing you as I'm walking around, but I'm also going to be collecting that paper from you, so make sure your group's names are all on it. If you want to put your group number on there, you can go ahead and do that too. So you're responsible for summarizing everything that you've done. Then the coordinator is responsible for getting the technology. I have a worksheet up here that you need to get for your group. Later on, we're going to be working with CBRs. You're going to be needing to get that technology also. And then the leader keeps everybody on task. And if there's any questions that the group has, the leader can address those to me.
The students work in groups to complete a worksheet that will help them discover the factored form of quadratic equations. The teacher circulates among the groups and monitors their performance. The teacher's management of group in-class work demonstrates content management, part of classroom management.
Keep looking for some patterns in the data. Have you guys discovered anything yet?
Yeah.
What did you
It's
discover?
Like the
Opposite of the factor
of
numbers.
x-intercepts.
The opposite. What do you mean it's the opposite? What is the opposite?
Like if it's a -3, -5, they're +3, x +3, and x +5.
Why do you think you use the opposites?
Something like one, because it's on the
Right.
Because it's
graph thingy.
It's just touching.
Axis, yeah.
Okay.
I don't know how you would find, for every parent function, there would be just the same number here.
I think it's just the same numbers in the inside, then it's like,
Do you know how to write that differently? X plus 2 times the quantity x plus 2?
what?
How can you rewrite this? It's number 4.
Plus 2 squared.
Yeah, can you write it that way? Write it as y equals parentheses. Oops, you're on the wrong one, Casey. Are you looking? Parentheses plus 2 quantity squared. Now what form is that in?
Vertex.
Vertex. And what happens when it's in that form?
Just moves to the left, too.
Just left 2. And that's why you only have one. That's why you have only one x-intercept.
The teacher demonstrates components of pedagogy when she has the students apply their new knowledge to a real-world problem. The students use TI-83 graphing calculators to look at the solution to the problem graphically. The teacher's use of technology and instructional resources enhances the students' understanding of factoring. By using mathematics to solve real-world problems, the students develop their ability to understand and apply specific concepts to real-world situations. The teacher's method of instruction and her interactions with the students display her knowledge of teaching practice, as well as a broad knowledge of mathematics.
We are going to apply what we just learned. We are going to answer this problem. And it says, suppose you have 24 meters of fencing material, and you want to use it to enclose a rectangular space for your garden. Naturally, you want to have the largest possible area for your plants. What dimensions should you use for the garden? Okay, so you are seeing some patterns here. As the width increases by 1, the length decreases by 1. Go ahead and draw the next 5 gardens for me then. You can fill in your table for the next 5. So let's fill in the area column. It would be 0, width times length,
11,
11.
20.
Okay, stop. Stop, stop, stop. Let's look at something. Increasing, increasing, increasing. Will it continue to increase?
At a certain point,
All right, 8 and 4s, 32. Then we have 35. And then we have 36. Oh, and then we have 35 again. Then we have 32. Okay? Do you see this right here? Is what we call our maximum area. And the dimensions would be 6 by 6. Okay, now what we're going to do is we're going to take a look at what this looks like graphically. What is the real world interpretation right now of x being 0, scroll down there to the left, and y being, nope, I can't, that's the best I can get. Who can tell me what that means right there? What's the interpretation of that? That's where you'd have the smallest area. Okay, right there. If you arrow to the top, if you scroll to the top, how do I know where the top of this is? How can I use the calculator to find the top of that parabola? Second trace. And we've never done this before. What do we want to do? Maximum. Let's take a guess. Anybody take any guess?
636.
636. Good. We already figured that out, didn't we? And there it is. Okay. So what does this tell me about the problem that I asked you? It says that if I have 24 meters of fencing, I should build my fence to be a 6 by 6 because that adds up to 24, and it would give me the largest area it would give me the maximum point of 36.
The teacher extends the student's understanding of factoring through an experiment. The students use motion detectors called calculator-based rangers to find out how high they can jump. Although the data the students collect is linear, they use a parabola to model the time the jumper leaves the ground to the time the feet return to the ground. The teacher displays an element of pedagogy by using technology and instructional resources that deepens the student's understanding of quadratic functions. And she has created a new learning environment that encourages investigation, cooperation, and communication in problem solving.
Now, we are going to use the CBR technology to do some live data collecting. You know, we generated that data. Now we're going to have the technology generate the data for us. You are going to be in your groups and you're going to be moving around, because what you're going to do is you are going to stand in front of this motion detector and you're going to jump. You're going to be able to figure out how high you can jump. And you're going to use what we've learned about factoring to help you figure that out. Now, here's what we're going to do to figure out your jump height, because this is measuring distance versus time. It's not measuring the height of your jump. There's a physics formula, and it comes from Newton's law of motion that is going to be on this handout that I give you. It's based on the force of gravity. It's an equation, and the equation is in the factored form. Who has calculated some jump heights already? We have. Okay, will someone in this group come over and explain to this group here how you're getting those values?
Do you have to solve it then?
Okay, what do you want?
They don't know what to do with those numbers.
I know.
I kind of do, but do we have to solve it then? Like,
Okay.
to make it equal to 0?
You put -192 in your y equals.
And then,
Okay.
-192.
Right.
In parentheses x, because you don't have a t variable in there.
oh, so I just
Minus your first time, which is time left.
10
Then you put the
point.
2 parentheses in there, x minus the second time, which is your landing time. Then you get your parabola.
Oh, and then we find that. Okay, I get
Then you find what, Holly?
the maximum or whatever, right?
Why?
Yes.
Because that tells you how high you jump.
The teacher demonstrates an element of pedagogy by integrating assessment of student learning into her instruction. The students have to interpret 2 graphs that model the same kind of data they collected with the calculator-based rangers.
Here's how I'm going to assess how well you understand what we did. We have 2 people jumping up here, Al and Allison. And we've got some information that's listed there for you. I would like you to tell me something about these 2 people. Okay? You also need to tell me something about when they took off, when they returned, what's the difference between their plateaus at the top. Tell me a story about these 2 people. What was her jump height?
345 centimeters.
345. We're still doing inches. 345 inches. Okay, now, I put that up there for a reason. What must have Allison had to do in real life?
She stepped away.
Just step like this way. She jumped.
like-
I read it.
She could have jumped out away from it and then jumped in. That would be good. One thing she could have done. What else could have she done?
Or held, like jumped onto something.
She could have grabbed up onto the lights up there, hung up there, and then landed. What else could have she done?